Hi everyone, this is the second video for the solutions of the 2023 HSC Maths Advanced paper. In this video we're going to look at questions 11 through to 22. Now I actually marked the HSC this particular year and I marked questions 11, 12, 13, 14 and 32. So as well as going through the solutions, I'll also give you some indication of where you received the marks. So question 11. First three terms of an arithmetic sequence are 3, 7 and 11. Find the 15th term. So we can see that A is equal to 3 and the common difference is 4, and that was actually the first mark. And we want the 15th term. And our formula is A plus n minus 1d. Substituting in we get 3 plus 15, take 1, multiplied by 4. So 3 plus 14 times 4. 14 times 4 is 56, plus 3 is 59. And the second mark would have been here, so substitution into the correct formula. 12a, table shows the probability distribution of a discrete random variable. Show the expected value e of x is equal to 2. Now this was a really curious question. It's only worth 1 mark, and your teachers would have said to you that with 1 mark questions you don't have to show you're working out. Not true. It says here, show that the expected value of e of x is equal to 2. And there was a really curious thing here with this question, where if you did the average of these x values, 0 plus 1 plus 2 plus 3 plus 4, divided by 5, you get 2. And this is completely wrong. So we know from our formula that e of x is equal to the sum of x times p. So we need to do 0 times 0 plus 1 times 0.3 plus 2 times 0.5 plus 3 times 0.1 plus 4 times 0.1, and then calculate that. It's equal to 2. So this line here is what you had to show. They allowed you to get away with it without putting down 0 times 0, but you had to show this in order to get the mark. 12b, calculate the standard deviation correct to 1 decimal place. Now we're given both of these formulas on the reference sheet. I tend to use and teach this one, but this one here is perfectly valid. So I'm going to work out e of x squared, and to do that I'm going to need a row for x squared. So I'm just going to take this row and square it. Now let's work out e of x squared. Of course it's going to come from x squared multiplied by the respective probability. So 0 times 0 plus 1 times 0.3 plus 4 times 0.5 plus 9 times 0.1 plus 16 times 0.1, which is 0.3 plus 4 times 0.5 plus 0.9 plus 16 times 0.1, which is 4.8. And now the variance is going to be e of x squared. Take away mu squared, we just worked out mu was 2. And that's 0.8. Now don't stop there, we don't want the variance, we want standard deviation. So standard deviation will be the square root of variance, it's meant to be a v, which is the square root of 0.8. And that is 0.89. We want it to 1 decimal place, so that's 0.9. Question 13. Let p of t be a function such that dp dt is equal to 3000 e to the 2t. When t is equal to 0, p is equal to 4000. Find an expression for p of t. So obviously we want to start by integrating. So p will equal the integral of 3000 e to the 2t dt. And integrating, we're going to get 3000 e to the 2t divided by 2 plus c. And all we need to do for our second mark is resolve this constant. So substitute in p is 4000. We've got 1500 here, e to the 0 plus c. c is equal to 4000. Take away 1500, which is equal to 2500. And at that point, we have the second mark. Question 14. Find the equation of the tangent to the curve y equals 2x plus 1 all cubed at the point 0, 1. Start by differentiating. We have a chain rule, so we're going to differentiate the outside function times by the derivative of the inside function, which gives us 6 brackets 2x plus 1 all squared. That was our first mark. Then we want to substitute in x is equal to 0 so that we get the gradient, which is 6 multiplied by 1 squared. It's 6. That's our second mark. Now you can either substitute into this formula, or you can recognize that that is the y-intercept and just go y is equal to mx plus b, which is going to be 6x plus 1, and that's the third mark. 15a, a table of future value interest factors for an annuity of $1 is shown. Part A, Mickey wants to save $450,000 over the next 10 years. The interest rate is 6% per annum, compounded annually. How much should Mickey contribute each year? Give your answer to the nearest dollar. Okay, so we're compounded annually. We don't need to make any adjustments. We have 6% and we have 10 years. So we want this number here, 13.181. So $1 is going to amount to $13.818 in how long? 10 years. He wants 450,000. So for setting up an equation, we're going to do x is equal to 450,000 divided by 13.181, which is, let me grab my calculator, divided by 13.181 is 34,140. Give your answer to the nearest dollar. It's 0.5 cents. Yeah, that's correct. B. Instead, Mickey decides to contribute $8,535 each 3 months for 10 years to an annuity paying 6% per annum compounded quarterly. How much will he have at the end of 10 years? So this time we need to change it, don't we? So instead of 6%, we're going to do every 3 months, which is 4 times a year. So 6 divided by 4 is 1.5. So that's here. And we're going to have 10 times 4, which is 40 periods. So the number we want this time is 54.268. And he is contributing 8,535, which is giving us, let's see, 54.268 times 8,535 is 463,177 and 38 cents. Question 16. The diagram shows the shape APQBCD. Shape consists of a rectangle, ABCD, and an arc, PQ, on side AB. And the side lengths are BC is equal to 3.6, CD is equal to 8, and the arc, PQ, is the arc of a circle, centre O, radius 2.1 metres, and angle POQ is equal to 110 degrees. What is the perimeter of the shape APQBCD? Give your answer correct to 1 decimal place. All right. So we'll start off with what we know. I'm just going to write a little bit of like an equation for this actually. So perimeter is going to be equal to, we want 8 metres plus we want 2 times 3.6. That gives us this, this, and this. We want our arc PQ. And then I want this bit and this bit, and I'm just going to call that X. Okay, so that part together is going to be X. All right, now let's work out PQ. So PQ, it's a proportion of the circumference. It's going to be 110 over 360 times 2 times pi times r, which is, let's see, 110 divided 360 times 2 times pi times 2.1, 4.03. And now we want to work out X. Now X is going to be equal to 8 metres, because that's all of that. Take away this distance here, PQ. Now it's a different PQ to the arc. I hope that makes sense to you. And we're going to get that one there by doing cosine rule. So PQ squared is equal to 2.1 squared plus 2.1 squared minus 2 times 2.1 times 2.1 cos 110, which is equal to 2.1 squared, and I want 2 of them, take away 2 times 2.1 squared times cos 110. It's 11.837. Run out of room, I'm afraid. We'll just put it over here. PQ then is equal to the square root of that. I've still got it in my calculator. So 3.44. And so X is going to be equal to 8 take away 3.44, which is 8 take away answer 4.56. So up here we have got 8 plus 2 times 3.6 plus 4.03 plus 4.56, sorry about the mess, equals, let's just work that out, 8 plus 2 times 3.6 plus 4.03 plus 4.56 to 1 decimal place is 23.8. And what are our units? Meters. Question 17. Find the integral of x square root of x squared plus 1 dx. I'm going to rewrite this as x and then x squared plus 1 to the power of a half. Now we've got a reverse chain rule here. The derivative of this is 2x, so what we really want is 2x sitting out the front so I can cancel out. Of course I can't just introduce a 2, can I? So I'm going to adjust it by putting a half here. And then we're going to have a half. Now let's integrate this. I have got x squared plus 1. It's a chain rule. Raising this by the power of 1 gives me 3 halves. Divide by that new power is 3 halves. I would be dividing by the derivative of this, which is 2x, but it's actually going to cancel out with that, so I'm not going to put it in. Plus c. All right. A half divided by 3 halves. That's a half times 2/3 x squared plus 1 to the power of 3 halves plus c, and tidying it up, we have our answer. Question 18, very wordy question. The university uses gas to heat its building over a period of 10 weekdays. During winter, the gas used each day is measured in megawatts. The average outside temperature each day is recorded in degrees Celsius. Using X as the average daily outside temperature and Y as the total daily gas usage, the equation of the least squares regression line was found. The equation of the regression line predicts that when the temperature is 0 degrees, the daily gas usage is 236 megawatts. The 10 temperatures are here. The total gas usage for the 10 days is 1840 megawatts. In any bivariate data set, the least squares regression line passes through the mean point. So x bar is the sample mean of the x values, y bar is the sample mean of the y values. Wow. Using the information provided, plot the point x bar, y bar, and the y-intercept of the least squares regression line on the grid. So we're told the y-intercept, it's here. So when x is 0, the daily gas usage is 236. Where's that? 236, it's there. And we want to plot this mean, these sample means. So we need to work out the mean there. We're told the total here, so we're just going to divide that one by 10. So y bar will be 184. And I'll just add those other scores up. So I've got 2 plus 5 plus 7 plus 8 plus 9 plus 9 plus 10. And divide it by 10. Don't really need to do that, is 5. So sample mean point is going to be 184. And plotting that, 184, I believe it's there. And part B, what is the equation of the regression line? So we just need to use those 2 points to work out the gradient. We already know the y-intercept, and then we'll substitute into y equals mx plus b. So our gradient is the difference in the y's over the difference in the x's. So 184 minus 236 over 5 minus 0, which is 184 minus 236 divided by 5. It's negative, let's do it as a decimal, negative 10.4. And so the equation of our line is negative 10.4x plus 236. 18C. In the context of the dataset, identify one problem with using the regression line to predict gas usage when the average outside temperature is 23 degrees. So let's use our line and substitute in 23 degrees. Is equal to, let's grab in a calculator, negative 10.4 times 23 plus 236 is negative 3.2. So we can see there that that is a problem because this is negative gas usage, which doesn't really have a real life context, does it? 19a, sketch the graphs of the functions f of x equals x minus 1 and g of x is equal to 1 minus x, 3 plus x, showing the x-intercepts. So let's start with this one. It's a straight line. It's going through 0, negative 1 and 1, 0. So let's just draw that up. It looks like this. So that's f of x. Get a different colour. Now this one here, it's an upside down, concave down parabola. It's cutting at 1 and negative 3. So here and here. The axis of symmetry is through negative 1, so let's just substitute that in and get the y coordinate. So 2 times 3 times 2 is 4. So it cuts through there. All right. It looks like this. Roughly. Part B, hence or otherwise solve the inequality x minus 1 is less than 1 minus x multiplied by 3 plus x. So we want to know where the red line is less than the blue line, which is obviously in between here and here. So we know this coordinate, it's 1, x equals 1, but we don't know this one. So let's just solve these simultaneously. X minus 1 is equal to brackets 1 minus x. 3 plus x, expand out the right hand side, 3 plus x minus 3x minus x squared is equal to 3 minus 2x minus x squared. Take everything over to the left hand side, x squared plus 3x minus 4 is equal to 0, factorise. X, factors of 4 that have a difference of 3, they are 4 and 1. We want the bigger one to be positive. X is equal to 1, which we knew, and negative 4. All right, solving the inequality here, we don't have less than or equal to, so it's going to be between negative 4 and 1, but not including either of those points. Question 20. Find all of the values of theta, where theta is in between and including 0 and 360, such that sine of theta minus 60 degrees is equal to negative root 3 on 2. So we have a trig equation. All right, so the first thing I want to do is do theta minus 60 is going to be equal to inverse sine of negative root 3 on 2. So we're going to need our all stations to central diagram. We want to know where sine is negative, and that's here and here, but I'm going to need to get the reference angle. The reference angle is going to come from solving, so we'll call this theta reference angle, inverse sine of root 3 on 2, so the acute angle in here. And that, of course, is 60 degrees, isn't it? All right, back to here. So this is going to be equal to, we want to go into here and into here. Now that is going to be 180 plus 60, and then in the fourth quadrant it'll be 360 minus 60, and that's 240 and 300. And then I'm just going to solve. So theta, I'm going to add the 60, it'll give me 300 and 360. Now that looks like the solution, doesn't it? It's actually not quite the solution. I'm always wary of equations that have either an angle that you're subtracting or you're adding, because there could be a third solution, and in this case there is. And it comes from going the other way, so going in a negative direction around this diagram or this unit circle into this fourth quadrant here and getting negative 60. all right? Because look what happens when I add 60 to it. I get 0, and 0 is in this domain. So our three solutions are, I should write them in order, but I'm not going to, 0 degrees, 300 degrees, and 360 degrees. Question 21. The fourth term of a geometric sequence is equal to 48. The eighth term is equal to 3 over 16. Find the possible value or values of the common ratio and the corresponding first term or terms. Okay, so from our formula, this is going to be AR cubed, and this one is AR to the power of 7. So we've got two equations we want to solve simultaneously. Now I'm going to do equation 2 divided by equation 1. So AR 7 divided by AR cubed is equal to 3 over 16 divided by 48. Right, that cancels. We've got r to the power of 4. Let me just do that on the calculator. 3 divided 16 divided by 48 is equal to 1 over 256. 1 over 256. And so r is going to be equal to plus or minus the quarter root of that. Where's that on the calculator? I think it's, I'll just do the power of 0.25. Can't find it. It's a quarter. Probably had done that in my head. Okay, so there's our two values for the common ratio. And now we just want to use, say, this very first equation here. 48 is equal to A multiplied by plus or minus 1/4 cubed, and solve for A. A will equal 48 divided by plus or minus 1/4 cubed. What's that? 48 divided by 0.25 cubed is 3072, and we can have plus or minus. And question 22. In the rectangular prism shown, AD is equal to 7, AE is equal to 8, EF is equal to 6, point M is the midpoint of CD. Find angle AEM to the nearest degree. Okay, so in order to do that, we're going to need to work out this line across here. And we know that that is a right angle. All right, so to start with, I'm going to work out the length of AM, and I'm going to use, I'll just go a different color. I'm going to use this triangle here, because that is also a right angle. Now we know M is the midpoint of DC, and DC will have length 6, so that will be 3 there. All right, so AM squared is equal to 7 squared plus 3 squared, which is 49, plus 9, which is 58. And so AM is equal to the square root of 58. I'm not going to use my calculator, I'm going to leave it in the exact form. Okay, so that there is the square root of 58. Now we're going to use trig, and that's going to be the tan ratio. So tan theta, this is theta here, is equal to opposite, which is the square root of 58, over adjacent, which is 8. So theta is equal to shift tan, 9 degrees I am, square root 58 over 8. Close my brackets. What do we want? Nearest degree, so 43.6. It is 44 degrees. Okay, that's it for this video. In our last video, we'll cover questions 23 through to 32.